We've been asked to find the relative extrema, or the maxes and mins, and the points of inflection for this polynomial. I've got a general cubic drawn here. As a reminder, when the derivative is 0, our slope is 0, so those would be the two highlighted yellow locations. That's when the derivative is 0. When the derivative is at a max, we will find our point of inflection, or potentially when the derivative is at a min. So we've got points of inflection where the derivative has a max or min. Zeros are where the derivative equals 0. So we need to take the derivative of f of x. That would be 3x squared minus 6x plus 0, because the derivative of a constant is 0, and we're setting this equal to 0. I can factor out a 3 and an x, and I have x minus 2 equals 0. So that means my zeros of my derivative are at 0 and 2. And a sketch can be helpful to determine when you have a max and min, so I'll plot 0 and 2. This is 3x squared, so it's a positive leading coefficient. I open up. That means my derivative is going from positive to 0 to negative. Positive, 0, negative. I've just made a max at x equals 2. Negative, 0, positive. I've just made a min at x equals 0. So I'm halfway to my goal. I also needed to find where the point of inflection exists, and we know that that's where the derivative will have its 0. That will be the minimum of the derivative. So if I take the second derivative of f of x and set it equal to 0, then I'm just taking the derivative of this. That's going to be 6x minus 6. We're setting equal to 0 because we're looking for that low point. When we do, we can factor out a 6 and get x minus 1 equals 0. It sort of looked like that's where my min would be, and sure enough it is at x equals 1. And I definitely change signs from negative slope to positive slope, so this is a point of inflection. Thinking about it another way, if I graphed 6x minus 6, it would look like this. And I would change from negative to positive, so that means for sure I have a point of inflection at x equals 1. Your PI, your max, your min, you're done.